I'm here representing Icom today. I'm not actually an Icom employee. I do some IT consulting in the Seattle area, and was the former president of the Microsoft Amateur Radio Club. Worked at Microsoft for a long time. Icom is right there in Bellevue, next to Redmond, Washington. So we got together for some various things, and after leaving Microsoft, I had lots of time to do things, and so I get to come do this. I'm not sure if that's a good thing or a bad thing, but here I am. My background obviously is mostly digital stuff, and my interest in amateur radio way back when was to try and send data and do some of that stuff. So this is very interesting to me. I don't get to spend nearly as much time doing it as I would like, but hopefully, I don't. How many people here have DSTAR radios already? Well, quite a few. So you guys know way too much already. All right. So I'll let you drive this because that was my concern. I didn't really know where we should focus on, what we should focus on here. So this is kind of an introductory thing, and maybe I'll buzz through this a little bit. If you have questions, stop me. If you want to talk about something else, we can do that too. So let me go ahead and start here. So what's in this deck is an introduction, kind of just a basic thing about what DSTAR is, kind of the advantages of DSTAR, how it works, some of the equipment that's available, band coverages, and kind of what you can do, and a couple resources. So it was originally, the spec itself is owned by the JARL, which is the Japanese Amateur Radio League. A lot of people, there's some misconception that people think somehow this is Icom proprietary. It is not. There are pieces. Interestingly, the only Icom proprietary piece is the gateway piece, which connects the repeaters together over the internet, and that's been reverse engineered. And Internet Labs can now sell you a DV dongle that uses that proprietary Icom protocol. So much for proprietary, right? Because you can buy it from other guys. So as proprietary as that is, it's available. People use it. They've reverse engineered it. There's actually a competing gateway system called IRC-DDB. So we can talk about that too. But so you can build a repeater today that uses no Icom hardware, connected over the internet to other things. It's available to any Icom, any of the DSTAR radios using no Icom hardware. So much for proprietary. The spec itself is open. The over-the-air protocol is open. The trick there is building a radio requires quite a high bar. I mean, if anybody wants to go try and build a radio that runs DSTAR, the spec is available. You can go to town. And you can see how many people jumped into that market, right? I mean, it's building a radio and marketing it and all that stuff is not a trivial thing. So Icom has done that work. It's likely at some point in the future we'll see someone else, but there's a pretty broad line of products, and I think you can probably find something for any application you might want. There's a couple different interesting things. The other thing about DSTAR is people talk about DSTAR as if it's one thing, but really there are two things. There's a digital voice mode that does voice and data simultaneously, very slow speed data. And then there's a digital data mode that's a very high speed data mode. So one of the things when we talk about DSTAR, I'll try to be clear about which one of those things we're talking about. But the radios themselves, the end user radios, what the Land Mobile guys call subscriber units. I love that term because it seems kind of meaningless to me. But so the actual end user radios, the actual handheld, mobile, whatever radios, all do FM too. So if you buy into a DSTAR radio and end up never using the DSTAR, you still have a pretty nice FM radio. I mean, you just paid a little too much for it is all right, because you didn't use the DSTAR functionality. So you don't lose anything by buying a DSTAR radio. It was introduced at the Tokyo Ham Fair in 2001, so it's been around a little while. And there's the thing about protocol is actually owned by JARL, and it's available in Japanese. Part of it's been translated into English. I'm not sure how much. I've only read pieces of it myself. It stands for Digital Smart Technology for Amateur Radio. So there's lots of digital protocols out there. Land Mobile is starting to move that direction. P25 is very, very common. DMR, which is Moto Turbo, some of these other systems. Icom and Kenwood are jointly marketing a system called NXDN, which is it's actually kind of a similar technology to DSTAR. Ultra narrow bandwidth, same kind of a little different modulation scheme, and it has a little different feature set because it's designed for commercial radio users who don't get to program their radios and don't get to fiddle. So this actually has some fiddly features. So you can actually do some cool routing things and all that stuff from the end user radio, which we'll talk about. It is an open standard. It is worldwide. There are repeaters connected to these internet gateways all over the world. Australia, Europe, all over the place, Asia. So the only piece of the DSTAR system that's truly proprietary is this DVSI codec. The codec's job is to convert your voice into a digital data stream that can then be sent over a radio. So Icom buys those chips from DVSI, and the trick is there's actually a pretty good reason for that. It turns out it's the only one available. It's the only one that's any good that's available. And it's the same system that everyone uses. So DMR uses it, P25 uses it, the NXDN products all use it, the new Yaesu System Fusion product uses it. It's the one there is, it's the standard, it's the best there is. So that's why it's in use. Unfortunately, I guess, is that these guys own it. So if you want to use it, you have to pay them for it. And Icom does that, as does Motorola and everybody else. So, and of course, Icom's the initial manufacturer of these handhelds and radios, but certainly there's an opportunity for anyone to come into that market if they chose to. Repeaters, obviously, you can build. A friend of mine, I actually have a couple friends that have DSTAR repeaters that don't have any Icom hardware in them. They've built them from scratch. So, and saved themselves a little bit of money, but in my mind, a huge amount of headache to go with it, but they learned a lot. That's what you say, right? When you had to do way too much work. I learned a lot. So, yeah. So, they're experts. So here's an example of the DSTAR network. The basic system, of course, and just like any repeater system, you can put this thing up on a hilltop and it acts like a repeater, and you can talk. The radios can talk simplex in DSTAR mode. They can talk through a repeater, to another repeater user in DSTAR mode. They can also link repeaters, and this is kind of what this is showing. You can link repeaters really to anywhere else in the world. You can link repeaters, or you can link a single radio over that connection. The other nice thing now is that Internet Labs has also created the DV dongle, which we'll talk about, which actually lets a random user over an internet connection connect into this system, and they can talk to an RF user. So from a laptop in a hotel room using free Wi-Fi, you can talk to an RF user somewhere else. There's also these DV hotspot things that they've also created, which lets you basically, well, I've seen a lot of guys do this. I'm not sure exactly what the virtue of it is, but they'll put a hotspot in their hotel room, connected to their laptop, connected over the internet, and they can use their DSTAR radio to talk through this little hotspot out to another RF user. So it's RF to RF, but it's using a little tiny hotspot device that's sitting around. So it has limited range, quarter mile maybe. You can, depending on what kind of antenna you put on it. The guy that Robin Cutshaw, who created this thing, went down to the Orlando Ham Fest here a few years ago, and he used one of those AT&T dongle things to provide his internet connection. He's put this whole thing in a little rack in the back of his car, put the antenna on top, and I've seen a couple of people do this. They'll caravan down, and they're just in the coverage of the hotspot all the way down the freeway. It only goes a quarter mile, so if they went too far, they'd be out of range, right? But they could be connected to the DSTAR network and on some reflector and talking with friends all over the world with their handheld radio as they roll down the freeway, right? So there's a couple interesting things about DSTAR. One is how easy is it to get a 2-meter repeater pair? Let's say I wanted to put up a 2-meter repeater pair here. Can I go out and get one of those right now? Does anybody know? You have
the frequency you have to get.
no 2-meter pairs available? Yeah, see, that's a problem, right? So on the land mobile side, on the commercial side, everybody's been going to narrowband, right? So instead of 25 kHz channels, which has been the standard on the commercial side, they went to 12.5 kHz channels. Well, this is actually ultra narrowband. It's 6.25 kilohertz occupied bandwidth. The newer radios are a little more spectrally efficient than the original ones, but so it takes a little bit wider channel than that. But certainly, if what we did recently in Washington State is we took a couple simplex pairs, 1 megahertz apart, and we turned them into a bunch of narrowband channels. So now we actually have narrowband only. They can be FM narrow, that's fine, but they have to be narrowband, and DSTAR qualifies under those guidelines. So if somebody wants to put a P25 or Moto Turbo, we have spectrum for that, but just those narrowband users. And the more people we can convince to go narrowband, the more spectrum we have available. And for some reason, hams, although we always complain about the lack of availability of 2-meter pairs, there are solutions available like going narrowband to narrowband modes, which can be analog, narrowband FM. Nobody's actually interested in doing that. It's far more fun to complain about not having 2-meter pairs or something. I'm not sure why that is, but so anyway, you do get significant spectral efficiency. You can pack 3 of these channels easily with guard bands inside a standard 25 kHz chunk of spectrum. You also get simultaneous voice and data, so we'll talk about how the signal is split up, but you get along with the voice, you get 1200 kbaud of data. And in that, it sends the routing information for the signal. If you have a GPS hooked to your radio, or in this case, the 51 has the GPS built in, it'll actually send my GPS location as part of the data stream. And I can actually send really any other random data I want. And there's some options that use that, but there's a really great program called DRATS that takes advantage of that I'll mention as well. So you can do basic, keyboard-to-keyboard functionalities. You could do file transfers, but again, it's a little less than 1200 baud because there's some routing information taken out of that. But and here's where the DD mode comes in. There's a high-speed data, meaning not 1200 baud. There's a high-speed data channel that's 128 kbaud, right, which is the same speed as an ISDN line, so twice as fast as a standard modem line. 128 kbaud data that's available at 1.2 gigs. So it is digital modulation. This is not with packet where you take you have an analog modem and you're taking the data stream and you're modulating it and you're sending it over at FM radio. This is a GMSK digital modulation. It's modulated that way as digital from the beginning. You can modify an FM radio to do this, but it is not FM. There is some relationship. So a lot of these guys will take analog repeaters, FM repeaters, and modify them for DSTAR use, but they do have to be modified. So the voice is converted from analog to digital by this codec. So you have a digital data stream that's 2400 baud for voice, and then there's a 1200 baud of forward error correction attached to that, and then there's still 1200 baud left over for data. So it's a 4800 baud signal that's being transmitted when you key up the radio. So that data might be empty. The data part is largely empty in most cases, but it does exist. And then, of course, you can go up to 128 kbaud on the 1.2 in the DD mode. Call signs included, and any routing information is included. And we'll talk about routing here in just a second. And you can see, so it defines if you're going simplex, or if you're going through a repeater, or if you're going through a repeater out to the gateway to some other internet location. All that stuff can be determined by what you're sending. There is a system called DPRS that's very much like APRS. In fact, it uses a pretty similar format, and it reports to the APRS server. So if you go to aprs.fi, for example, and I'm connected every time I transmit on an internet-connected gateway that's running the software to pull this off, which is most of them. My information is being passed off to the APRS IS server, and then on that APRS network, I'm going to appear as a node, just as if I was running APRS. You can do repeater linking, so a lot like Echolink functionality. I can do that as well, where I can link a repeater to another repeater over an interconnection. The one interesting thing about, so unlike Echolink, where you have to understand what node you're going to at the other end, the DSTAR network actually keeps track of all the users and the place it last heard them, much like a cell phone network does. so that if you decide you want to contact someone, I don't actually have to know where they are. I can just put in their call sign and then key up, and the network will find them and connect me to the node that they were last heard on. So just like making a cell phone call, right? It doesn't, I have a Bellevue, a Bellevue phone number, but I don't have to be in Bellevue to use my phone, right? And nobody has to know that I'm here to call me, right? The cell phone network has already figured out that I'm here. And the same thing is true with DSTAR. So unlike normal ham systems like Echolink or IRLP, where you have to actually know what node you want to talk to, and you have to know they're listening on this particular one at this time, this network will at least attempt to find you. So you can also connect, we talked about the DV dongle. You can connect from a PC without any radio. There's also the ability to do the low-speed data, which gives you some kind of chat-like functionality. With a program like DRATS, you get some chat functionality. You can actually send small photos. You can transfer files. Again, all at 1200 baud, so there's no magic there. I mean, it takes as long as it takes, but it does work. And of course, if you have high-speed data needs, 128K baud is a pretty substantial speed for over-the-air broadcasting or transmission of data. So as far as interfacing goes, the low-speed data, all of the radios have a jack in there that's a sub-mini jack that just does RS-232 data. So it's super easy. You can get the cables from Icom, you can get them on the internet, whatever, that connect up, and right to your PC. And this DRAT software that's the one. Again, there are multiple packages out there. I'm just very, very impressed with the performance of DRATs and the functionality that he's built into it. So you can actually send messages, files, whatever. And you can do that simultaneously with the voice. I wouldn't necessarily recommend that. Again, you're only doing 1200 baud, so if you were trying to send a file, it's reasonable enough to try and chat, a text chat thing while you're talking. Otherwise, you get a bunch of funky transmissions with nothing but data and no voice and whatever. But it can be done. It does actually send them at the same time. And certainly the APRS-like functionality, that's all happening while you're transmitting your voice, all independent of what you're doing. As opposed to, if you're using an APRS system, you usually have, the common one is a dual band radio. The way I used to do it, I had my Kenwood D700. I had APRS on one VFO, and it was dedicated to that. And then I had my other one that was my voice radio, my voice channel. And I could set them, one was always set to the APRS channel, and one was always set to whatever one I wanted to talk on. So I had this really nice dual VFO, dual band radio, but it was really only one because the one half of it was dedicated to APRS. In this case, it's all done at the same time over the same channel. So this is a dual band, dual VFO radio that actually is a dual band, dual VFO radio because I don't have to dedicate the one to APRS. On the high-speed data, the ID1 is the radio out. There was a recent price drop. It has been pretty expensive. I think now it was right at $1,000, and now it's in the $700 range. And it provides us 128K baud data. The interesting thing about it is it uses a standard RJ45 connection, so it looks like a network. And it just acts, it's a very dumb device. It doesn't do anything special. You get two of these radios, put them on the same frequency, put them in the DD mode, and they talk. That's all there is. So you plug in stuff and data goes over it. It's basically just an internet cable without the cable. It's a wireless bridge at 128K baud. So it makes it actually pretty cool for doing some kind of event. If you want to provide some low-speed internet connectivity, it's good for emails, things like that aren't necessarily, if people want to try and stream video, you're kind of hosed. Or if they want to do the latest Windows update, that's going to be a problem. But other than that, it certainly can provide you useful bandwidth for basic web browsing or whatever. So the system itself, I don't know how many systems you guys are aware of in this area. I kept forgetting to look. I was going to do that this morning. 5. Can we hit them from here?
2 in Dayton, 1 here, 3 miles away, 1 in Kentucky, just over the river, one in Wilmington,
Cincinnati.
and in Cincinnati.
Oh, nice.
Columbus.
Yeah, so you have there's a fair selection of radios. There's actually, I mean, of units around. There's a reasonable penetration. Obviously, it's a chicken and egg problem, right? So areas, it's always interesting to see, nobody wants to buy a DSTAR radio until there's a DSTAR repeater they can hit, right? And then nobody wants to put up a DSTAR repeater if they have no users. That's always been the problem. Now that the system is about 10 years old, the repeaters literally were released in 2003. So now that the system is about 10 years old, we actually have some decent penetration, and it's a useful system. And you can see here, you can see the growth. This is just of the Icom DSTAR gateways. Now you can actually get these non-Icom DSTAR gateways. These are not counted in this number, not represented on this chart. So if you were to add those, it would actually be significantly higher. In fact, I think the number I saw more recently was somewhere between a third and a half of all the gateways are actually non-Icom gateways. So this graph would be substantially different looking, and that's all in the last couple of years. Again, the repeater systems, these are just Icom repeaters because they're hooked to the Icom gateways. And users, again, if you're using these things, you're not talking on a gateway connected system, we'll never know who you are.
They say that number is 40% of all of them. So the 60% are the
Non-ones? Yeah, the last one I saw was pretty much, worldwide that could be. Because it's certainly, I think the guy that developed the first one was David Lake out of the UK. So in Europe, there's a lot better penetration of the non-Icom stuff. So this chart actually isn't even representative of the whole DSTAR community. As a DSTAR user, you would have access to the Icom and the non-Icom stuff. So the DV dongle is basically a little tiny box with a USB connection on one side, and that's it. Its sole job is to convert the data stream coming over the wire, in this case because it's hooked up over the internet. So it's getting the digital audio stream that's in DSTAR format and converting that to audio that your PC can play for you. So you can plug in headphones or listen to the speaker, whatever, and it'll convert DSTAR audio. So much like Echolink can do kind of natively, this lets you get that functionality where you can plug into the worldwide network and participate without any other infrastructure, with only an internet connection. So a lot of people, when DSTAR, this was really popular early on when the DSTAR network, the actual repeater network, wasn't so well built out. People wanted to play on DSTAR and they wanted some way to do that, so you could buy a DV dongle and play. The software is available for Windows, Mac, or Linux. What else do we need to say here? Yeah. It does give you the ability to connect both repeaters and reflectors, and you can do data. Here's that DV access point. These guys, it's got the little tiny antenna, but it's an SMA connector. You can put a little larger antenna on it. This is a VHF thing. You can put it on a simplex channel and talk to it. And it gives you the ability to use your standard DSTAR radio with this device plugged into a laptop or desktop, whatever, and generate, some amount of DSTAR coverage within your, around your house, around your vehicle, around a room, whatever. So we could plug one of these things in here and put it on the air. Ray Novak, the sales manager for Icom, has this cool little one. I don't know who built it for him. They put it in a little Lexan box so you can see the whole thing. But it's a Raspberry Pi, so that little tiny single board computer for $35, right? It's a Raspberry Pi with one of these things and a little, like an AT&T wireless dongle thing plugged into it. So that's his hotspot. He can take that thing, just turn it on anywhere. Oh, and a little battery pack in the very bottom of it. The whole thing's like yay big. He can just take that thing anywhere, turn it on the air, and then you've got DSTAR, a DSTAR repeater effectively, that you could access from your handheld radio and participate in the network. So it has some, and I think they're working on, I thought I saw there was a dual band version or a UHF version of it coming up, and I haven't seen that yet.
He's working on the dual that is called
So it is dual band. Yeah, I was thinking, there's been noise about it, but I haven't actually seen one.
He
So
said he's working on it. I don't know when we're gonna come out with it.
I was gonna say, it's been a while he's been saying that, but yeah.
I see.
So there's a couple, so here's the basic layout. On the 2 meter band, there's the DV mode, the digital voice mode available, and there's radios available for that. 70 centimeters is, again, the DV mode only, so that's the voice and the low speed data. On 23 centimeters, on 1.2 gigs, you can have the DV mode and the DD mode, because there's enough bandwidth up there. This channel is like 130 kilohertz wide to get this 128 kbaud data. So it requires a lot more spectrum, and worldwide, that's only available at 1.2 gigs. Unique call sign, has to have its own unique ID, and all this stuff is done by call sign. So, so you have to set up, so you can't use your own call sign for a repeater like you can on FM, because you're not just IDing the repeater, it has to be a separate entity on the network. So you do need to get its own call sign. And then there's a number of different repeater modules available. These are, again, the Icom ones, but 2 meters, 70 centimeters, 23 centimeter digital voice modes. And then this, the high-speed data module is available as well. You also need the controller, that RPT2C. And then, of course, the rest of it is kind of based on where you're putting it and all that stuff. But so you'll still need, duplexers, all the rest of the stuff that you need for a standard repeater system. Duplexers, power supplies, antennas, maybe some kind of filters, internet connection, entrance panel, blah, blah, blah. So here's an example of the DV mode, right? We've got 4800 baud data. It's broken into 2400 baud voice, 1200 baud forward error correction, 1200 baud serial data. And then there's the routing, the call signs themselves that can be used for routing. So a lot of people have a hard time with it's always interesting to me, because I think if new hams come in and were to learn DSTAR, they would probably find it easier than FM. There's less to know. All you really need to know about a DSTAR system is the frequency, and you kerchunk it. The repeater will come back and will automatically program your radio for you. It'll put its own call sign. Well, the radio will see the call sign of the repeater, and it will put it in the RPT1 field. So now you're talking on the repeater. Whereas with an FM repeater, you have to set it up. You have to put in the frequency, and then you have to get the tone, right? So you have to get the tone, then you have to turn on the tone, because of course setting the tone is completely separate from turning on the tone, right? Which is one of the two steps people generally screw up. Like, oh, I got the right tone. Yeah, but it's not on, right? And with this, you don't actually have to even do that. Now, if you want to do some of the other routing features, it can get more complicated, right? But the basic repeater operation or simplex operation is very, very simple. When you first buy the thing, you put in your, you put in the my call, you put in your call sign in the radio. You only ever do that one time. And then if you want to route, there's some things you can do. You can decide there's two different routing options. There's site routing and user routing. And site routing, I'm going to connect to another system, another gateway, another reflector, where multiple users hang out. Or I can connect to a specific user. So I can do call sign routing to a single user. By default, there's the way that the ports on the repeaters are identified is by letter. So this is just the defaults. 23 centimeters are called A, 70 centimeters B, 2 meters is C, and the gateway is G. That's appended to the call sign, and that's how you can identify. I want to go out the 2 meter module, and I want to come back, and then I want to go out the gateway. So I can put the call sign, space, whatever. In the 8th position, you have that letter, and that's how you determine what the call sign is. So you can see here, WD5ERD. Who is that? Anyway, that's the call sign. That's the call sign of the user. Repeater 1 is KE7WTBB. So that's the name. That's the call sign on the repeater. That's a 70 centimeter repeater because it's B. And then it's going to go out the gateway. So it's also going to be available on the gateway. And then the UR call is CQ, CQ, CQ. That just means he's going to key up, it's going to go out the repeater, it's going to get rebroadcast to everybody, and it's going to be available on the gateway. So if there's a dongle user connected to that gateway, they're going to hear it too. If that repeater is connected to another repeater, linked to another repeater, they're going to hear it too. And here, if I wanted to talk to a specific user, all I have to do is put that user's call sign in the UR call field. The system will go find them, and you'll be coming out on that system. And this is if I wanted to connect to a specific machine. So I transmit this, and my call automatically goes out this K5TITB, so I end up coming out on 70 centimeters in Texas from wherever I am. So there's a couple things. One of the other confusing things I should mention about one of the things that people get confused with is DSTAR is because Icom is not the only solution provider, I should say, is maybe the right way to say it. There's certain, the Icom gateway software is obviously available from Icom, but there's a bunch of other extensions that have happened by various people, and there's another whole gateway system, and it operates just a little differently, and the names are a little different, so it gets a little confusing for people because they see these other things. So, and you look in the manual, and the manual talks about there's a bunch of features in the manual that you'll never ever see on the air because no one implements them. This concept of zones and all this other stuff. Nobody does that. It's available, it's in the DSTAR spec, the radios support it, no one uses it. So it's a little confusing in that respect because there's features that aren't mentioned in the manual that are available, and there's features in the manual that the radio support that no one actually implements out in the real world. So one of the things is reflectors, for example. Reflectors are not an Icom thing. This was also something that Robin Cutshaw developed. And there's this thing called D+, and he created a bunch of extensions to DSTAR, and some of them are pretty trick. One of them is the echo test. If you put the repeater call sign in with an E at the end of it, when you transmit, it will take your voice and retransmit it back to you. So you don't have to ask for a radio check. You can do your own radio check, and you don't have to rely on someone else's interpretation of what your voice quality is. You'll hear it yourself. You will hear exactly the way you sound through the repeater. It just records you and replays it back. That's not an Icom feature. That's a feature that was put in there by someone else. There's an info thing. You can find out if the repeater's currently linked. There's a bunch of cool things that you can do with these by just changing this letter in the call sign. So there's the echo test. You can link and unlink the repeater. Again, that's whole linking, the reflectors, all that stuff that exists. These are basically conference bridges on the internet that you can connect these DSTAR repeaters to. Those conference bridges are none of that stuff is done by Icom. They weren't developed by Icom. So the latest manuals do mention some of those things finally, because people were complaining that they weren't in the manuals, but Icom doesn't have any control over that. They can change the way they function at any time. The list of reflectors changes over time, not significantly, but there's like 63 reflectors worldwide currently. So here's a short list of some, Arizona, New England. Anyway, this is showing how to actually link by adding the link and unlink commands. So the very latest generation of radios are interesting because they have, this is one example, the ID51. It includes the GPS built right into the radio. They also have memory cards. I have a little micro SD card in the side of this thing. I think it's only 4 gigs or something. I got some tiny little card. It gives you the ability to record audio, and it stores a repeater directory for the entire United States. So I can download this repeater directory, put it on the card. It actually the radio comes pre-programmed with the repeater directory, whatever. I'm not sure how often they update it, but it does come with one built in. So the nice thing about it is instead of having to program all the call signs and get all that stuff right and wait, was that 7 characters or 8 characters and getting the letter in the right spot, all that stuff, you can just pick it off the list. The reflectors are in there on a list. The repeaters are in there on a list. So I can say I want to go into this repeater and I want to talk to that reflector. And you just pick them from lists. and then boom, you're done. You're connected. For emergency communications, that's kind of my primary focus right now. I work part-time for our local county doing emergency communications. And well, there's a couple interesting things about it. One is you have this nice failure mode of if, people say, well, what if the internet's not available? Then, then DSTAR is useless without the internet. It's like, well, certainly some of the functionality is not available if that's there. But worst case, it's the same thing if you have a FM repeater with echo link, right? The internet goes away, you don't have echo link. You just have an FM repeater, right? I mean, everything else is still there. It's still a repeater on a mountaintop. And you have all that functionality, except now you can still do voice and data, which before with FM you would have only had a voice repeater. With this, I still have some other functionality. I still get my location data. I could still transfer, text messages. I can do all of that stuff through a repeater that I can't do with an FM machine. If you do have internet connectivity, then you can actually, you can do all kinds of interesting linking capabilities over long distances. You can use these reflectors that don't have to be located anywhere near where you are. They could physically be anywhere. The other cool thing is it doesn't, one of the problems, I don't know how well you guys are organized, but I know one of the problems we have is if I wanted to talk to one of our city EOCs, some random city EOC, I really don't have any way to know what frequency they're on. I don't know where they're monitoring. In the case of DSTAR, I don't really have to. All I have to know is their call sign, right? I can do a call sign route to them. I can keep the mic and call them. And the system, as long as they've checked into some node that's still on the air, I mean, the odds of you having an internet disruption that expands, it spans multiple states are pretty unlikely, right? In fact, it doesn't really happen. But it's certainly possible that a power outage or a lightning strike has knocked out a system, or a tornado, or none of that stuff we have. But earthquakes, we have earthquakes. Earthquakes could certainly take out a significant amount of infrastructure, but it's still unlikely to take out all the infrastructure. And all we have to do is one time kerchunk some repeater that we can hit, and boom, now we're registered with the system. Anyone can put in our call sign and they can talk to us. Guaranteed. That's a capability. Certainly, even if I know what frequency somebody normally uses, if that's knocked out, wow, now how do I get a hold of them? I really have no idea on an FM system, right? I wouldn't know how to do that. Well, and then of course because of these conference bridges, you can hook up really any number of users from anywhere in the world. The guys in the southeast actually often have like hurricane nets that they'll set up. They'll span multiple states. They'll get on a particular reflector. They hook up all the DSTAR repeaters into that reflector, and everybody can be monitoring this one huge net. Of course, you can still do texting with it. They did another exercise here not too long ago in Georgia, where they actually went and they took pictures in the field and then transmitted them all back, which was kind of an interesting test, because it's getting higher speed. Well, how do you say this? Served agencies are getting far more interested in high-speed data, and the data capabilities. Not for the data part of it so much as they just expect to be able to send I need this spreadsheet to go over there. I need this document to go over there. Or I want to send this photo somewhere. And as hams, I think we're kind of missing out on the fact that we need to figure out a way to do that, because it's just expected that can be done, right? Because everybody has that capability in their pocket. So how is it that we can't do that, right? So DRATs, I mentioned this. If you haven't ever looked at this, it's very cool. Dan Smith has been at the Dayton Hamvention now for I don't know how many years, showing it off. Icom buys him a little booth and puts him in the main arena, and he's got a little demo station there where people can come play with it. It's very easy to install. You don't have to have a DSTAR radio. Recently, he's upgraded it, in fact, so that not only will it work just generically over the internet with this feature that he calls a RAT flector. So DRATs is DSTAR spelled backwards, right? In case you didn't. Anyway. And then, so he created this thing called a RAT flector, which allows you to hook RF connections to the internet. So you can come in, you can have internet users and you can have RF users. They can all connect to this thing, and it supports like chat, keyboard-to-keyboard chat functionality. It'll send out, you can do beacon messages, so you can send out a little status text or whatever every so often. You can specify what that is and how often it goes. You can do file transfers with error detection, so guaranteed delivery of files. Again, it's 1200 baud data, generally, if you're doing it over the RF link. So you have to be careful about getting too crazy. One of the nice things he does is photos. He does automatic sizing. So if you take a picture, he automatically scales it down so that it's only a few K. And there's a little slider bar so you can adjust how much. If you need more resolution, you can crank up that little slider bar. Just be aware of the time penalty that that's going to incur at 1200 baud, right? You have what they call structured printable forms. So he does this really nice thing where he actually, you can send the form as a separate file, and then you're just sending the data for the forms. And when they reproduce, he has like an ARRL radiogram and an ICS 213 form and a Hicks 260 form, which is a hospital ICS form. When they print out, they look flawless. They look exactly like, the FEMA ICS 213. They're fantastic looking. No one would ever know that it, went through some other system. It looks like you just typed it in and printed it. He also does GPS position reports with mapping. He has, there's some open source mapping product he connects to, and so all of the radios, as they report their locations, can be plotted on a map in the system. You can directly read and respond to WinLink email messages. He's got an email system built into it. And, and then I think he's stopped adding features at this point as best he can, but he's doing a lot of bug fixes. The latest one of the last features he's added is standard packet support, or support for packet modems anyway. So if you have people that are running legacy systems, and this is one of the things that I want to try and promote in our area, we have some guys that are just like, yeah, but we already have all this packet stuff that we've already got running. It's like, okay, fine. So I can gateway that through this Ratflector. I can have those guys connected on one side, and I can have our local DSTAR users connected on another side. They're all running the same software. They have all the same functionality. They don't really know the difference, other than it's a lot easier for me to hook up a DSTAR radio because I just plug in the cable, and they have to go through, packet stuff and get all the TX delay and blah, 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 all that other stuff set up with packet, which you don't have to do with DSTAR. There's a cool website, dstarusers.org, that actually shows you can go to live. It's live. It shows all the connections to this worldwide network. It used to be, one person would key somewhere in the world, and then you'd wait, and then someone else would key. But now it actually scrolls by relatively quickly. Every time you refresh it, it used to be a really cool way to make sure that you were showing up on the worldwide network, because you would key your radio and it would show up here. But now it's a little less useful because there's so much activity. But it is kind of fun to see where all the users are coming from, literally all over the world. There's also a dstarinfo.com website, which has some fantastic resources. There's a couple training videos on there. And there's the complete listing of nets and reflectors. You can also get the repeater list to update your latest version of the Icom radios. The DSTAR calculator. DSTAR calculator is a pretty cool feature, so I kind of glossed over the routing a little bit because personally, I think if you spend any time using that DSTAR calculator, with the cool thing with the calculators, you can go in there and say, okay, I'm here in Cincinnati and I want to go, use this repeater in Cincinnati and I want to talk to someone somewhere else, a repeater, reflector, whatever else. You can just pick them off lists. And a lot of the functionality of these radios, I think, is kind of patterned after that calculator. And then the calculator will show you, these are the settings you need to put in your radio. And so you'll see that right away. And then you can just put that in your radio. You can save that in a memory channel if you want, and then you can reproduce that at any time. The latest radios, of course, can do that internally, but if you have an older model radio, that DSTAR calculator is very, very cool. And of course, there's news and then the listing of all the reflectors and what they're used for and all that stuff. Nets, any nets that take place. I can't remember. I saw some list of. There's a couple hundred nets that take place worldwide on DSTAR, actually. So you could certainly waste a ridiculous amount of time doing that if you chose to. And then here's some other. There are a couple good This DSTAR Digital Yahoo group is very, very good. If you have any questions, that's a fantastic place. A lot of the guys I see posts from Robin Cutshaw, who made the DV dongle. There's another guy in our area who's a big fan of this other system, IRC-DDB, this other gateway software. Those guys are all very, very active on it, and they're eager to answer questions. So it's a fantastic resource for. You'll find. I'm sure you can find several different ways to accomplish what you want to do if you ask those guys. And that's all I had. Any questions?